Hello, Pre-AP Chemistry. How are we doing today? Hopefully y'all are doing well. Today we are going to be starting our Unit 11 notes over thermochemistry. So let's go ahead and get started on this. So first off, for thermodynamics or thermochemistry, we do need to know the first law of thermodynamics. Now, basically what this is this is going to tell us that energy cannot be created or destroyed, but it could change form. And so one thing that we know is that the universe actually has a certain amount of energy, and that energy is constant. Now, it is being constantly moving from one place to another, right? So it's constantly in motion. But we do have this constant form of energy. And that's basically what the first law of thermodynamics says. Now, in this transfer of energy, in this energy moving from one place to another, we do have the system and the surroundings. And the system is basically where we are focusing our studies. So, where we focus our studies. So, it's basically the observation, what we're actually observing, what like when we're doing a chemical reaction, the actual reaction that's taking place. That is going to be what our system actually is. And so this is going to be basically the reaction, typically in chemistry. Now, the surroundings are basically everything else. And this does include you. And so you will be classified as a surrounding. Now, the time that you would not be classified as a surrounding would be if you are the focus of a study, right? But for the purposes of chemistry, we do use the reaction as our focus. So it's going to be the system. And then you and everything else is going to be what we classify as the surroundings. Okay. Now, we do know that heat will transfer. And heat is going to transfer because there is a difference in temperature. So anytime we've got a difference in temperature, that energy is going to move. Where does it move? Well, it moves from hot to cold. Okay, so from hot to cold, from high energy to low energy. So we're always going to see that movement in that direction. And so a lot of times what I'll tell my students is, you know, in the summer when your parents are griping at you because you're letting the cold air out, you can be like, no, I'm actually letting the hot air in. Now, I don't suggest you actually do that with your parents, but it is really what's happening in terms of chemistry. That energy is moving from the high energy, the hot air outside, to the cold energy, which is inside. Okay? Now, this is always going to be spontaneous. Now, remember, spontaneous means without any assistance. It just happens, okay? And so there is this spontaneous transfer of energy from warm to the cooler object, okay? Until we reach equilibrium. And equilibrium is basically where those temperatures are going to be the same, all right? Now, when we are working with heat, we do actually work with calories. Now, there are two types of calories that y'all may or may not know about. There is the little c calories, which is basically small c calorie here, and there is the big C calorie right here. They mean two different things. The little c calorie is what an actual calorie is, all right? The big C calorie is a kilocalorie. Now, the big C calorie is actually what we find on the food label on the back of like a bag of chips or a candy bar or something like that. So when we look at the big C calorie, it is a kilocalorie. So what they tell you on the back of a bag is actually 1,000 times more than the number that they're actually telling you. Okay? Now, in terms of calories, calories actually represent an amount in joules. Remember, joules is energy. If you're taking physics, you have talked about joules before. But that conversion is 4.184 joules equals 1 calorie, 1 little c calorie. So 4.184 joules equals 1 little c calorie. All right. Now, we know when we have a change in temperature, the biggest way to figure out what that, or the simplest way to figure out what that change is actually going to be, is you take your final temperature and you subtract your initial temperature. So your final temperature minus the initial temperature. And remember that the little triangle there, so right here, that little triangle represents the change. And so when we've got that triangle T, that represents the change in temperature. And it is going to be measuring the energy that's transferred during a chemical reaction or a physical process. And that's the only way that we can determine the amount of energy that's actually inside of the system. Okay? Again, remember that your heat transfer is going to be from hot to cold when we're looking at that. So do remember that. Do keep that in mind. Now, in terms of physical transfers of energy, and again, this is by physical means. So by physical means, there are three types of energy transfer that we deal with. We deal with radiation, conduction, and convection. Now, radiation is actually going to be the transfer of energy across a distance. And this is going to be via electromagnetic radiation. So it occurs when warm or hot matter emits electromagnetic radiation and it's absorbed by an object over a distance. Now, it does have to be at a distance and it does have to involve electromagnetic radiation, which, remember, with your EM spectrum does include light. Okay, so typically what we're going to be looking for is some form of a light source or that EM radiation, and that's going to be that energy transfer across a distance. Okay, we talk about an X-ray machine, right? That is an energy transfer across a distance. We talk about a fireplace, how that will actually warm us up, right? That is an energy transfer over a distance, and it does, both of those do involve things from the EM spectrum. Okay. Now, another example of this would be the sun. This is the most common example of radiation that is actually occurring. Okay. Now, next one is conduction. Conduction is going to be the transfer of heat through physical touch. You actually have to touch this, whatever it is. And so if I'm talking about, okay, I've got a lasagna cooking in the oven, and I reach in with my hands, just bare hands, and I grab that pan of lasagna, what's going to happen to my hands? Well, they're going to burn, right? Well, they burn because of that conduction, that transfer of heat through physical contact, okay? And so another way that we could see this is a grilled cheese. How do we make that? Well, we take 2 slices of bread, we add some cheese in between them, and we put that on a skillet. Now, the bread on the skillet side will actually toast, right? Which will then cause that transfer of heat through physical means to that cheese, and then that cheese would actually begin to melt. Then what do? You flip it over. Why do you flip it over? Because that transfer of heat needs to happen on the other side of the grilled cheese as well. Okay. Next one, convection. And this is the last one that we're working with in terms of physical means. So a convection type of heat transfer is going to be a transfer of heat within a fluid. Now, do remember that a fluid can be a liquid or a gas. It doesn't have to be a liquid only. A lot of times that is a common misconception. But a convection is going to be anytime we've got a transfer of energy or heat through a fluid, and this is going to be by movement of currents. Now, the most common example of this is a convection oven. Now, how does a convection oven actually work? Well, all it is there's a little bitty fan on the inside of the oven. When you flick that switch to turn on the convection oven, all it does is it turns on that fan, which causes the air to then move around. What does that do? Well, it causes the heat to be more evenly distributed around the oven, right? Instead of the heat just coming from the bottom or from the top, it's now going to come from all directions. And so that's the purpose of the convection oven. And again, that would be those currents that we see. And so we see that heat transfer happening because now we've got that movement of energy. All right. So what I want y'all to do is I actually want y'all to give this a try and label each of these things as conduction, convection, or radiation. And you can come back and check your key when you're all said and done. And then if you do end up with some questions, then by all means, don't hesitate to reach out to us. But double check this, but go through, work all 10 of these problems, and then come and check your key when you're done. All right? All right, so now let's actually take a look at enthalpy. Now, enthalpy is basically going to be the heat of the reaction. So it is the heat of the reaction. And we do typically represent this with, again, that H, like this. And sometimes you'll see it as a delta H because we're representing that change in heat, right? Okay, so the definition. So enthalpy is going to be the amount of energy either absorbed or released during a chemical reaction. So it's basically that energy and heat that we see. Okay. Now, we have two types of enthalpy that we talk about. We talk about endothermic and exothermic. Endothermic is going to be the movement of heat from the surroundings to the system. Okay, so it's going to come from the outside and be actually absorbed into the system. And I tend to remember this by remembering endothermic means to enter. So we're talking about that heat entering that reaction, being brought in to that reaction. Now, for this, what we're going to see is that it is going to actually, so the surroundings, since you are a surrounding, will feel cold. Why? Because that heat is being absorbed away from the surroundings. It's going to be taken from the surroundings and being brought into that reaction. And so it's going to feel cold. Why? Because it's taking heat away from you. Okay. So in this case, for an endothermic reaction to occur, we're going to say heat is, and we can either say is required. We could say that it is stored, or we could say that it is gained. Any of those things would work. Now, for this, it is going to be a positive change in heat. And we are going to find that there are bonds breaking as a result of this endothermic reaction. Because it takes energy, we have to absorb energy to break those bonds. Kind of think about it in terms of a rubber band here. If this rubber band keeps absorbing energy from me stretching it out, what's going to eventually happen? Eventually, we're going to see that rubber band break. Okay, and so it's kind of the same thing with our chemical bonds that we have as well. Next, we have exothermic. And exothermic, it is going to be the opposite. So we're going to see the movement of heat from the system to the surroundings. All right, and I remember exothermic by remembering exothermic means to exit. So the heat is going to exit my system. Now, in this, we're going to see that the system, your surroundings, being your surroundings, you are going to feel hot. Why? Because now the system is sending heat out and away. And so since you're a surrounding, you're going to be absorbing that heat. So it's going to feel hot or warm. Okay. Now, in this case, we see that heat is produced. We could say that heat is released. And we could also say that heat is lost. Any of those things would kind of describe what's going on there. Now, in this, we see a negative change in heat. Why? Because that heat is being lost. It's being released. When we see bonds form, it's because that is going to be a more stable way of that actually holding everything together. The only reason bonds form is because it is a more energy efficient way for those elements to actually be combined. And so with an exothermic reaction, we see bonds forming. All right. Okay. So pull this ink back up. So for our delta H, we know that delta H, that triangle, represents change. So the triangle represents the change in enthalpy. And so to solve for the change in enthalpy, we do products minus reactants. So I've always remembered this by saying it's hot in Puerto Rico. So for our heat, it is products minus reactants. So your change in heat equals products minus reactants. So it is hot in Puerto Rico. Now, a positive value indicates that the products have a greater energy. And so that tells me that the heat was absorbed. And so we could also say that it was required for that. So it had to actually absorb that for the reaction to occur. So we required it, it was absorbed. Okay. In terms of a negative value, that's going to indicate that the reactants have a greater energy. So again, positive value, your products have a greater energy. Negative, the reactants have a greater energy. And so what we see is that energy is released, or we could say that it is produced. Okay? Now, that little degree sign is going to signify that the reaction is a standard enthalpy of change in standard states of matter. Okay? A standard state is going to be something like a solid, a liquid, or a gas. That a pure substance can be found, something that you would basically find on your periodic table. Okay? And then the last thing is, like right here, we see this RXN. That RXN represents the reaction. And so in that case, we've got the delta H with the little circle sign, that degree sign of the reaction. It's basically saying I've got my change in heat. And in this change in heat, we've got our standard states of matter. And this is all happening as a part of a chemical reaction. And so it's given us a little bit more information about what's actually going on. Now, in this next part, we have to determine whether or not these enthalpies are going to be endo or exothermic. So do keep in mind that if I've got a negative change in heat, that means that heat is being released. So this is going to be exothermic. If I've got a positive change in heat, that means it is being absorbed. So it is endothermic. Okay, so I want y'all to go ahead and do those next 4 problems. So pause your video, do the next 4, and then you can check your key for the answers to that. Now, another thing to note is that when we're talking about those enthalpies, those positive or negative changes in heat, those can be actually represented in a chemical equation. And when we see that, this is what we call a thermochemical equation. And basically it's saying I've got a chemical equation, but I've also got some thermodynamics in there, that change in heat, right? That change in enthalpy. So a thermochemical equation shows my actual heat as a part of that reaction. Okay. Now, looking at this, I do have right here a negative change in heat, but I've also got my heat on this product side. Again, 2 different ways that I could write that reaction. This is exothermic. Okay, because again, we're releasing that energy. So since the energy is being released, it's being produced. And since it's being produced, it is a product. Okay, and so we do see this right here. And so again, energy is produced. Okay, now looking at this reaction, now we've got a positive change in heat. But again, I could rewrite it with my heat on the reactant side. Well, if my heat's on the reactant side, that means that energy was required. Or we could say that it was absorbed or it entered that reaction. And so we would call this an endothermic reaction. Okay. And so basically, when all of that, what all that comes down to is that if we've got an exothermic reaction, we say that energy is a product. And if it's endothermic, energy is a reactant. So, y'all, that is it for our first set of thermochemistry notes. Please let us know if you've got any questions, but otherwise, y'all have a great rest of the day. Bye, y'all.